I want to thank you all for joining us today for our first of our Cadre Spring Symposium series, Real World Open Science. And before we talk about open science, I wanted to start by introducing a little bit about Cadre and what the organization is. We are an informal group here at OSU that is basically, with the whole mission of advancing digital research and education. We meet usually 2 to 3 times a semester, and we discuss everything from new tools and research of interest, things that we feel are important to communicate back to our respective organizations. The Cadre Group is currently, the council is composed of about half faculty researchers and about half research support organizations are represented, such as the library and high performance computing, the VPR's office, and so on. And I would like to make sure that everybody with an interest in digital computing research feels free to join us. We have a website, and the contact information can be found there. You can contact Clark or I, and we would be more than happy to put you on the mailing list. And you may know Cadre best from our past conferences, which this year, after being faced with a third year potentially in a row of having to do a conference virtually, we decided to mix it up a little bit and use a different format. So this year, we're holding the symposium series in the place of the Cadre conference. So we have some dates scheduled here, February 23rd, March 23rd, and April 13th. We're in the process of finalizing speakers and topics for those upcoming dates. And so please check the website for details for future events. And I should introduce myself. My name is Katie Orman. I am the Research Data Initiatives Librarian at the OSU Library. And my colleague, Clarkia Kavakis, the Scholarly Services Librarian, will be doing our first presentation on research sharing drivers and inhibitors. And then I'll talk about using fair data to make open science work. Kara Moore from the psychology department here at OSU will be presenting on a researcher's perspective of open science. And then Deja Penny and Aaron Smith from OSU IT will talk about data security and open science. And then we will finish up with a question and answer period. I would like to encourage you to put any questions you may have into the question and answer that's at the bottom of your screen there in the toolbar. And some of you submitted questions in advance. We'll make sure to address those as we go. And if you have any other questions or concerns, please feel free to drop those in the chat. We have enabled the closed captioning. So if you would like to take advantage of that, you can go to the, Clark just put the instructions for how to enable the captions into the chat. So we encourage you to do that if that will make the experience more enjoyable for you.
Hello, everyone, and welcome, and thanks for joining us today. I'm Clark Iakavakis, and I am the Scholarly Services here at Oklahoma State University Libraries. And the subject of my talk is research, sharing, drivers, and inhibitors. And I'm going to give sort of a bird's eye view of what is a very large and complex topic and with the hope that if there's anything you'd like to pull apart and discuss in more depth during the Q&A portion of the talk, encourage you to do so. So as a quick outline, I'm going to start off with a quick scan of some of the recognized benefits of data sharing. And then we'll look into some of the data sharing, what inhibits and what can drive forward data sharing, and a few different dimensions of that. So I'd like to start with a quote going way back to 1995 that says, an article, this is specific to computational science, an article about computational science in a scientific publication is not the scholarship itself, it is merely advertising of the scholarship. In this case, for the actual scholarship is the complete software development environment and set of instructions. Generalized more, we could say that in some research projects, the data, materials, and the methods have more potential downstream use and impact than the research article. When we talk about research data sharing, to be specific, we're looking at making primary research data publicly available, preferably in an online repository upon publication of the article associated with that data. And there's this whole sort of spectrum to data sharing, where on the one end, there is the data shared that is only the minimal amount necessary to reproduce the findings reported in the article, all the way up to the final data set, multiple data sets from the raw, processed, and the final data set. And then taking that a step further, the code and any other materials that would be necessary to reproduce the research results. These benefits of sharing data are, at this point, fairly widely recognized and agreed upon. Data sharing can lead to greater transparency of the research process, cooperation, and collaboration. Certainly from a funder's perspective, data sharing is cost efficient and can help prevent redundancy and funding duplicate studies. Potentially and ideally, data sharing can lead to acceleration of innovation and discovery. And I like to look at this plot that looks at the reuse of Hubble Space Telescope data, where they find that papers based on the reuse of archived observations, in which at least one author, there is no overlap between the paper authors and the original investigators, exceed those based on the use described in the original proposal. So this is kind of the leading edge of the potential of secondary or downstream data reuse. We also see benefits in the form of policy formation and public health. Of course, we're all thinking about coronavirus, and just last month, the CDC presented their data modernization initiative that looked forward towards a much more interoperable data landscape. Data sharing could potentially guard against research fraud and enable reproducibility, potentially mitigate publication bias, in as much as the article, the journal article is less valued than the other products that have gone into developing the article. We may potentially see a reduction in selective reporting, where we often see a bias towards reporting positive rather than negative results, or novel rather than confirmatory results. Data sharing could lead towards a landscape away from that circumstance. Providing data promotes student reuse and data literacy, where students may struggle collecting their own data. And finally, data sharing could contribute to increased citation and usage of the research article. The reason I put a question mark here is because I think that we're still learning whether or not that is true. There have been a couple of studies, or several studies, that looked at this question. One here found that in a set of cancer clinical trial publications, the 48% of trials that had publicly available data received 85% of the aggregate citations. And then another study found an association between of up to 25% for articles that included a link to a repository that linked to the data underlying the study. Of course, this doesn't imply causation. There may be specific enthusiasm or synergy around those articles, or perhaps those articles that share their data put more effort and resources into the paper as well, but it's still an interesting and important question. Data sharing is associated or tied to reproducibility. This plot looks at a set of papers in applied computer science where the researchers attempted to reproduce those research findings. And out of the original set of 613 papers, they were only able to reproduce 102 of them. Most of them, you can see down here, either received no email, or the email reply and attempt to get the data was no, or the email simply bounced back. Now, availability. So this is another theme of my discussion here. Availability of research data alone does not enable reproducible research. And this is something that Kay is going to discuss in more depth. So what are some of the drivers and inhibitors of research data sharing? Something that comes up often in research that investigates this question finds that issues of promotion and tenure and status is often related to factors other than data sharing. So contributions to the discipline, publication output, novelty of results, the prestige or citation metrics of the journal, service to the community, and so on. So we really do not see a significant number of university or departmental policies that incentivize or reward data sharing. A lot of those extrinsic incentives we're seeing come from the publishers. And I'll review briefly some of the ways that we are seeing that. More and more publishers are requiring data sharing statements where when authors submit an article, they're required to describe whether their data is available and where their data is available. These are options from the journal BMJ, where it's a spectrum all the way from data are available in a public open access repository all the way down to no data are available. Taking that a step up, we see some journals requiring data sharing as a condition of publication. For instance, Public Library of Science, PLOS, requires that authors make all data necessary to replicate the study's findings publicly available without restriction at the time of publication. And in fact, publication is conditional on compliance with this policy. And if restrictions on data access come to light afterwards, they do have some repercussions. And in fact, these teeth have been shown. This is an example of an article in Exercise Science in PLOS One, where the researchers were requested to provide individual level data sets. They had discomfort with that, saying that they didn't want to publicly release individual level patient data, and instead offered to release aggregated data from the study. And that was not sufficient for the editorial board. And so they issued an expression of concern. Further on, some journals require open data as a condition of submission. And this is the very small number of cases. But here, F1000 requires that all methodological details and data are made available to others to replicate the study. Now, these data sharing statements are more or less effective. I think that the research is still being conducted on whether or not this leads to more data actively being made available. One study in ecology and evolutionary research found that these journals that have very strong data sharing policies, out of the data sets they retrieved, 56% were incomplete and 64% were archived in a way that partially or entirely prevented reuse. So, and a similar study was undertaken with PLOS that found the same thing, that really it ended up that only a minority of data sets were publicly shared. We are starting to see more journals specializing in publishing articles that describe data sets or code or methods or protocols. For example, a data journal is a publishes peer-reviewed articles that describe publicly available data sets that have no results or conclusions, but include technical information that might be left out of traditional peer-reviewed articles. Going back to other factors mitigating or inhibiting data sharing, when grant funds are not specifically allocated to data archiving, research has found that researchers maximize the portion of their funds expended on research, what they call research proper, rather than what they see as secondary support functions like data management. So this kind of ties in and is complementary to what Kay will be talking about when she discusses fair data, when data documentation is seen almost as competing with the research aims rather than essential and critical to achieving those aims. This is, of course, a reference to data management plans, which have been around for over a decade at this point, where funders require that researchers describe what data they'll be collecting, how they'll manage the data, and what they will do with it afterwards. There's an important distinction here, though, between data management and data sharing. And one study really looked at that distinction and found that though a majority of publishers do require data sharing plans, in other words, specify that recipients of awards will be expected to share their data, really written data management plans were not required by a majority, and a low percentage of funders actually required a DMP after the award, which the researchers concluded that this suggests a disparity of emphasis on pre versus post-publication management of data, and again, a failure to recognize data management planning as integral to research from the outset. Other concerns include a lack of control and concerns about misuse. So where is the data going to be stored? Who will be using it? How will they be using it? In one study, 80% of researchers found that, or stated that control of shared data is paramount. And this is understandable. Using other researchers' data requires domain expertise, and misinterpretation is indeed a serious risk. Again, this speaks to the extensive documentation and description. And the further a user is from the point of data origin, the greater the risk of a misinterpretation is. Other concerns include issues of acknowledgement and credit. Of course, there's a desire to publish results first, so that can inhibit release of data before any studies or all studies tied to that data set are complete and published, and a fear of not publishing findings before secondary researchers do. Some wish to receive acknowledgement as in the form of co-authorship, at least formal acknowledgement of the source of the data, or even an opportunity to collaborate. Now, some of this can be dealt with proper data citation. And over the last several years, we've seen both norms and technologies that have enabled citation of data. So data sets can be assigned unique identifiers, digital object identifiers, DOIs, which enable them to be individually discovered and cited separate from the paper. And DataCite is one organization that has really pushed this forward. Data citation promotes reproducibility in as much as there's a link between the paper and the versions of the data and the code used in that paper. And publishers have really moved forward in implementing changes to the structure of their published content to allow these links. We also see the development of dynamic documents where description and code are embedded all in one executable file. Finally, we also see lack of training and skills in data archive and management as an inhibiting factor, where researchers may lack training in methods, standards, formats, and state that they'd be more likely to share if they receive institutional support. Funders have stepped in to provide some of this. I would put in a plug for some of the programs that the OSU library develops towards this end, like Carpentries and Databytes. OSU also maintains an institutional repository that you can use to deposit your data if you are an OSU researcher. And then the last concern surrounds ethical and legal issues, needing to make sure that there is consent and anonymization, questions about data ownership, and data licensing. And that's all from mine. Thank you very much. Okay.
Thank you, Clark. That was a good lead in here. Okay, we have one question in the Q&A, but I think would you like to address it now? I think it's a clarification question.
Yeah, that's a great question. Are we talking about raw data? Are we talking about process data? Are we talking about final data? And we see a huge amount of variation depending on the funder, depending on the researcher. We see any and all. So ideally, in an ideal environment where they're reproducible, you can take the raw data set and see all files processed from that data set, including and up to the final data set. But not all funders require the raw data to be made available. And similarly, not all journals require that raw data to be available either.
Clark touched quite a bit on both the advantages and the challenges, but some of the challenges that we recognize for open science and making our data open is some of these listed. And so I'm going to address how can fair data help. And, most of us have, most of us have heard the term fair, but one thing you may not realize is that fair data principles directly address machine usability of data. And that is something that we are, that's increasingly our reality. This graph is one that was taken from Statista, our database that the library provides. And although it shows a graph of volumes of telecommunications data, the expansion of research data is, by all indications, on a very similar exponential growth. And so for your research data to be accessible, it's going to also need to compete in that world. And we talk about big data in terms of the 5 V's of data, of big data: volume, velocity, variety. And due to those factors, it must be machine readable and actionable to have value. Humans can interpret the subtleties, but computers cannot. So without having a good structure to the data, it's not going to be, the computers are not going to find it. And as Clark has already mentioned, the most important and persistent product of research is data. And so that means that for your data for your research to have value, your data must be out there. So in 2016, a working group of the Force 11 Scholarly Communications Group developed the FAIR data principles, the seminal citations down there at the bottom. And so the question is, what is FAIR? Well, FAIR is an acronym, and it stands for findable, accessible, interoperable, and reusable. And that may still be a bit murky. Findable simply means that you have a unique, persistent digital identifier, and that you provided enough metadata that that data set is going to be searchable. Accessible means that it is stored somewhere where it can actually be accessed, which means not on a thumb drive in a desk drawer or even on a lab computer. And some of the statements that are included in publications that Clark mentioned, the traditional way, preclude making data truly accessible. That doesn't mean that it can't be behind an authentication and authorization. Some data is secure and needs that control behind it if there's personally identifiable data or some other privacy issues. The thing that probably causes people the most confusion is the concept of interoperable, because to be interoperable basically just means that that the data set that you're providing can also be combined with other data sets in a way that makes them useful. And so for that to happen, there has to be a common language, semantic plan. And using appropriate ontologies and controlled vocabularies are the ways that you make that happen. We'll look at an example that goes into this a little bit in detail, but metadata is not, the language of the data is not uniform. If you work in, even within a larger discipline, biomedical, you'll find that data terminologies and research terminologies vary widely. And so an ontology is basically just an organizational strategy. And the one that I find to be the most easy to understand is the one that we all learned in high school for classifying living organisms. So kingdom, phylum, let's see if I get it right. Kingdom, phylum, class, order, families, genus, species, right? Yeah, so that's it. And so that's the idea. Within the very large category is a series of smaller ones. Controlled vocabularies are language that have been agreed upon by a given community to describe something. And so ontologies have the controlled vocabularies underneath them. And you may have to cross-reference between ontologies to find out whether a vocabulary that's appropriate for one type of description is still appropriate in another discipline or subdiscipline. And then finally, we talk about reusable. And for something to be reusable, it has to be well enough described using descriptive metadata, as well as documented provenance. And that just basically means all of the information that someone needs to know about how the data was collected, how it was stored, analyzed, sampling. All that information has to be available, because otherwise that data is completely meaningless. And licensing, Clark touched on that a little bit. You need to tell people how, what it is okay to do with your data. And just a few guidelines around FAIR principles. FAIR principles are not rules or standards. They're not rigid. They're guidelines, and they're really meant to help researchers that choose to make their data fair. And so, it may take baby steps to achieve fair or close to fair even. And it's not an overnight process. You can implement some aspects of fair without implementing all. And you should also be aware that it applies to both the data and the metadata. So the digital identifiers need to be available for both, for example. And so as an example, I think that identifying the right ontologies and controlled vocabularies can be the most difficult for people who are starting in a new area, especially. And so this is an example for those in the biomedical field. This is available through the National Library of Medicine. And they provide a searchable repository of common data elements. And you can see, hopefully you can see its tiny little print, but each of these is for a different area. And and you can see it also shows the number of elements under each. Some of them are very large and some of them are not. Some of them are quite general. National Library of Medicine has their own. And then some of them are very specific under Global Rare Diseases Patient Registry Data Repository, for instance. But that's an example. But let's talk about it in plain English. In essence, FAIR principles are guidance for data management practices, improving your data management practices. And it can be kind of murky to understand, what these things mean. So this is a slide that was actually used by Dr. Corey Giles in a workshop I attended last week. And because it's in nice, simple English, I asked if I could use it. And so it's used with permission. And basically, it starts at the very bottom with what he called data redundancy. And basically, that is just how careful are you with your data? Do you back it up on a regular basis? Are you careful to do quality control and make sure that it's not corrupted, et cetera? Linking data and metadata, we talked about the need to use both and have digital identifiers for both. They need to talk to each other. Archiving and local searching. Do you have a carefully planned strategy for archiving your data locally? And can you find it when you need it? Code and pipeline reproducibility. Have you created a reproducible environment? And Clark touched on reproducibility as far as making things available so that people can reuse it, and also be sure that they get the same thing you do. And then finally, external submission to a data repository. This requires a significantly higher level of data curation, description, and so on. And in essence, when you have completed all the layers of curation that are needed to make your data submissible to an external repository, you have probably achieved FAIR data. So I'm going to use this as an example. This was taken from a publication. The citation's down there at the bottom, and the publication is actually in code. It's a software that they are developing for data table management. And so I encourage you to read more about it. They have a GitHub repository that provides all the software and all the documentation, a lot more information, as well as the publication. But I selected it because it shows a really good example of how carefully structuring your data can move you towards that FAIR data. There are two types of metadata described here. The first one is structural metadata, and the other is descriptive metadata. And this is all taken from an experiment that was done on tomato fruit. And it was a designed experiment looking at different factors that affected the growth of the tomato fruits. It was very complex. It required, I think, a dozen very large data sheets collecting data in the greenhouse manually for hundreds of tomato plants. And then from those tomato plants, there were 1,000 samples that were, had lab analyses done on them. So all of that data had to be organized in such a way that when they got ready to do the statistical analyses for the designed experiments, that they were, making sure that they coordinated the correct analyses and descriptions and so on with the correct plant. Because for those that have done designed experiments, it's very easy. Small slip-ups can result in completely garbled and meaningless results when you get to the point of doing your analyses and modeling. So in this example, there are two spreadsheets shown, and the number one at the top, called plants.txt, is the one with the plant information description, and the one called samples.txt is the analyses for the samples taken from the plants. They have to be linked. So you see that there's a plant ID category in both. And so this is kind of like the key term in a relational database. One has to speak to the other to keep them straight. You see a B there. It shows the categories for the different types of information. And so the identifiers are the sample ID and plant ID, but you have factors. And so those are levels that you can organize or sort by to more easily manipulate your data. And then you have both quantitative and qualitative data types that are organized in such a way that when you get ready to do your data analysis, it's easier to, using your R or Python, it's much easier to sort and select that data and run the analyses. In essence, what this does, this process, it creates the structural metadata up front. And so, one of the things when I teach data management classes is I encourage people to think about the data management plan as a process that begins right from the start. And so this is an excellent example of how you can make your life much, much easier by making it easier to do the analyses by creating that structural metadata. So the bottom two, there's a structural metadata spreadsheet. They're shown by C, and you can see that each different term is listed, and you can see that the plant ID and sample ID are cross-referenced, and they come from those first two spreadsheets. The last spreadsheet there shows the finer levels of detail. So in this case, for each attribute, there is descriptive metadata, and those ideally are cross-referenced from a ontology and controlled vocabulary. So this is, I hope, an example, a subsetted example of a best practice for organizing data in spreadsheets and making it so that you can actually find what you want without having to go back through and risk errors, risk losing things, B, not spend hours and hours doing what the authors call data archaeology. Okay. All right. So with that, finally, let's talk about reusable. So we talked about creating both structural and descriptive metadata. The structural metadata, as you saw hopefully from that example, is critical to interoperable. It's critical to making sure the right things link up and data sets can be combined. Descriptive metadata is critical for the last phase, which is when other people want to use your data. So there's layers. If you are archiving in a publicly accessible archive or repository, such as Figshare or Triad, there will not be so many rigid requirements or guidance for how to curate your data. However, domain-specific data sharing repositories will have some requirements about how the data is organized and described. I listed some examples there. Also, if you are at a point where you're looking to find a repository that is either general or domain specific, but domain specifics are the ones that are harder to find. They have registries of repositories. So the re3data.org is listed there as a place to search. And again, please use the license as a way to make sure that you are making it clear how you want your data to be used. And the Data Curation Center is a good resource for information for finding metadata schemas, as well as just general guidance for data management and curation. And this is the full citation for the paper that I referenced there. And with that, I am going to stop sharing, and I am going to turn it over to Dr. Kara Moore.
So I'm going to be talking about open science from a researcher's perspective today. And I wanted to start with just a quick disclaimer, really, that this is going to be open science from one researcher's perspective, and that perspective is my own. And the reason why I wanted to mention this is that there is a whole host of open science principles and open science tools that can be used. And different tools and different principles may be better well suited for one researcher than another. And so there is just a whole lot of diversity with regards to these open science approaches and what might fit for any one given person. And I know that's certainly the case for me. Okay, so since this is going to be from my perspective, I wanted to share a little bit more background information about myself. So I think you should now be able to see my face. That's great. So I am a psychologist here at OSU, and I study attention and memory in the legal system in human children and adults. And I teach and mentor undergraduate and PhD students in research. During the 2019-2020 academic year, I was a fellow for Project Tier, which is focused on teaching how to document analyses so that they're reproducible. So during today's talk, I want to talk to you about what brought me to the world of open science. I want to talk about my experience with open science tools, particularly with documenting my analytical workflow and teaching students to do that, pre-registration and registered reports, open data, and preprints. And I'll talk about each of those in turn today. So first, what brought me to open science? What really brought me into open science from the get-go was an interest in effective and efficient teaching and mentoring in research. So I worked somewhere else before OSU. I worked at a small liberal arts college called Knox. And there, as part of my teaching, I mentored senior psychology majors through a senior thesis research project, completely up to them what that topic was going to be. And what I discovered through this experience was that we ran into a lot of difficulties with me being able to provide effective mentorship to students when it came time for them to do their analyses. They would do their analyses on their own and then write them up or share their output with me. But oftentimes, since they're learning how to do these analyses for the first time, they would run into problems. And then I would be playing the role of detective, or as Kay mentioned, archaeologist, really, and trying to kind of reconstruct and figure out what they had done in order to provide them with mentorship on what may have gone wrong or how to adjust. And that was quite difficult to do. So that brought me to this workshop at the project tier in 2018 at Haverford College. This is an initiative led by Norm Medeiros and Richard Ball at Haverford. And Project Tier is really based around this software agnostic guide to documenting how you handle and analyze your data to create analytic reproducibility. So from there, I was able to implement this process in my undergraduate statistics courses and in my research mentorship of senior research, but also in my own lab with honors students and graduate students, so that when they were going to do analyses, they were able to document what they did to allow us to have a more effective mentor relationship overall. And so that really was the major benefit for me up front of doing this, was being able to create a reproducible workflow to allow for me to provide more effective mentorship to my students and troubleshooting. I've also found in my own research work that this makes it much easier when we need to add, tweak, rerun, or change analyses. So just as a quick example, we had a paper that we submitted for review relatively recently. And after we had already run the analyses, one of my students realized that there was a variable that needed to be recoded. And if we hadn't documented our analyses, we would have had to recreate everything from scratch to correct that error. But since everything else was already documented in syntax or code, we were just able to quickly change that variable and click run to rerun the analyses without having to remember what we did previously or rerun the analyses in their entirety. I think the cost to implementing something like this in one's workflow, at least for me, has just been the time to learn the process and to teach it. But it has been very worth the time to me to take the time to learn, to be able to be more efficient overall. Next, I want to talk a little bit about pre-registration and registered reports. Pre-registration is this practice of registering one's hypotheses, method, and or analyses before data collection or before data analysis. The Open Science Framework is one home for pre-registrations if you're looking for a place to do a pre-registration. For me, implementation of pre-registration involved starting off with one project and pre-registering it. And since then, I've been doing a slow rollout so that now nearly all of my research projects are pre-registered. And then a similar format is registered reports. Registered reports, though, are a new publishing format that focus on the research question and methodology as opposed to the significance of the results. So with a registered report, a person submits their introduction and methodology for peer review before collecting data. And if the paper is accepted, then the journal agrees to publish the results regardless of their significance. So with implementation of registered reports for me, I found that they've been feasible for some of my projects, and I find them to be particularly advantageous for what I'm calling risky projects, but are really projects where we may be less confident that we're going to obtain statistically significant results, but the research is still important to run. So registered reports allow one to combat that publication bias, where many outlets don't want to publish null results. So I'm going to do a combined slide for pre-registration and registered reports, benefits and cost. I think benefits are to both are clear documentation, avoidance hypotheses, and advance the data collection. So this helps to demonstrate that best practices are being conducted. One isn't reporting hypotheses that match the results after the fact. It also, this has been very advantageous for me, allows you to outsource your memory for your project. You have this really nice record of what you were thinking and planning when you got started, and you don't have to reconstruct that however long after you started you go to analyze your data. And that's been increasingly important for me over the last few years. My memory has gotten worse and worse. Next, this allows you to outline your research plans in advance so that you can develop stronger, more well thought out research. That's definitely been the case for me. Writing things down and outlining them has helped to make my research much stronger and to avoid gaps. And lastly, it allows you to avoid the file drawer effect overall. That's true with pre-registration because one can find that pre-registration online so that in meta-analyses, null results that may not have been published aren't missed. And with registered reports, the results are published either way. Two more benefits to registered reports are receiving peer review before the research is conducted. I have found this to be incredibly valuable. Getting peer review on my research plan has allowed me to strengthen the plan to have an overall better research product. And with registered reports, there's the guarantee of publication, regardless of the statistical significance of the results. Costs, like with analytical workflows, really the time it takes to write these things out. But again, I found that to be very worthwhile for me. And with registered reports, there's the time that it takes to wait for the peer review process up front. The goal with registered reports is for this to be much quicker than the traditional peer review time. I haven't had a ton of experience with this, but in my limited experiences, I've had varying experiences with how long it takes for that peer review process to happen. And so for someone who is, say, a student, having to wait to get started on data collection might not be feasible. And for early career researchers, I think that's something to be very strategic about, because with front loading that peer review on like initial annual evaluation, for example, it might look better to have that data collected than to be kind of at the stage of peer review initially. All right, so next I want to talk a little bit about open data, which has been the focus of our symposium so far today. So you know what open data is by now, the sharing of data with or without restrictions. The Open Science Framework is, again, a home for open data if you're looking for one. For me, I found that this has been feasible to implement for some of my projects. Benefits of sharing data are increasing scientific discovery by allowing data to be used by other researchers, whether it's once you're done with it or beforehand. Increasing collaborations. So I've had a collaboration that came from my posting of my dissertation data. So if I hadn't done that, I don't think the database would have been in a place that another researcher could have picked it up and understood it. And so by the act of getting the data ready to be shared allowed it to be then possible to have these new collaborations and this additional work done with my data that otherwise would not have been possible. And of course, this also enables others to work to reproduce your findings. Costs and downsides to sharing data openly are just navigating the human ethics issue with anonymity and consent from your participants, making data fair, and the time associated with the efforts to share the data. And lastly, I want to talk about preprints. So preprints are a version of a scholarly or scientific paper that precedes formal peer review and publication in a peer-reviewed or scholarly journal. Implementation, preprints could be posted before, during, or after peer review. Benefits to preprints are increasing accessibility to your work for people who may not have access to the journal that the work is published in, but also getting your work out there a little bit earlier than what would be done if you waited on peer review to happen. You can get credit through your preprints. They can be citable, and you can get additional feedback beyond that peer review process by posting a preprint before or during the peer review process. I think the major cost and downside from my experience has been learning how to navigate complicated publisher posting policies. Fortunately, there's a really nice resource called Sherpa Romeo, wherein you can type in a journal's name and quickly get some very easy to understand guidelines about what you would and would not be allowed to do with regard to posting various versions of your manuscript with that journal. So overall, I think the downside to open science is just the time that it takes. From my perspective, it's always been worthwhile, though. It just takes time on the front end to learn. And sometimes there are costs in terms of time at the beginning of the project, more so than at other points in the project, as opposed to a more traditional workflow with research. Upsides are more effective and efficient science and scientific mentorship, getting more feedback and attention to your work, more opportunities for collaboration. And for me, it's definitely built up my confidence in my work and knowing that it's reproducible, it's accessible to others, and things along those lines. So I think my general philosophy with regards to open science is that it's not all or nothing. And I would encourage you to explore the tools or techniques that you think might be beneficial to your workflow. Right. That is everything that I have. So I'll turn it over to our next speaker. Thank you all.
Good afternoon, everyone. My name is Aaron Smith. I'm the interim director with OSU's IT Security Office. Today, I'll be joined by Daisha Penny. She is our manager for the IT Risk Management Office. And we're here to talk to you about data security at OSU and managing potential risk associated with open science. Daisha, have you got the slide deck? There we go. I will start off by just kind of a preface and say that Daisha and I are not routinely involved specifically with research. But we were asked to participate to kind of help provide a little bit of an outside perspective from a security standpoint when it comes to the topic of open science and open research. So starting off, I'd like to say that security is really about culture. It's going to involve everybody. It involves everybody that's a part of the community. It's something that we're all going to be working together. And it's something that my office specifically plans for. It's something that my office specifically works towards. So we'll talk about some of the things that my office does, and then we'll also talk about some of those things, right? Some of those things that are currently going on that we're dealing with. But then we'll also talk about some of the future things and some of the things that we will be working on and doing going forward. So like I said, security, it's our thing. That's the thing that my office does. And we provide security for just across the institution, from enterprise systems like Banner ERP, foundational university assets, all the way to secure storage solutions for somebody on a mobile device that's working remotely. We encompass everything in between, obviously including research data. So that's what our office is here for. We have all of these, like you see on the slides. We have numerous tools, numerous solutions. We have staff trained for using all of these things to help protect that data. So what are we protecting against? Well, we're protecting against those things, right? The bad things, the things that are trying to get the stuff that we're trying to protect. So here's just an illustration of our defense in depth posture. It incorporates obviously several layers of protection to protect data here at OSU, right? So just some quick examples of some of these bad things, some of the things that, some of those things, right? The Log4j vulnerability. Last month, there was a critical vulnerability that was discovered in the widely used Log4j utility. Attackers could exploit that vulnerability and gain access and control of systems that they were targeting. So within hours, though, of that vulnerability being discovered and being made public, we already had protections in place to help protect vulnerable systems on campus. We also began initiatives just to proactively identify systems that could be vulnerable and started working with the system owners to help protect them, to help get those fixes in place. Another example would be malicious emails. In the last month, we've blocked over 1.1 million malicious emails. And what do I mean by that? That could be phishing emails that are trying to steal your credentials, emails with malicious attachments that could be trying to infect your computer to steal your data. They could be financial scams emails that are trying to steal your money. And then finally, ransomware, right? Ransomware is a big one of those things, right? It's one of those things that has been highly publicized. There's high profile targets recently, like Colonial Pipeline last year, but even local targets like City of Tulsa or the Stillwater Medical Center, they've been experiencing those things. So those are the type of things that our office is working to try to protect. Now, what does this have to do really with open research, right? Here I am talking about vulnerabilities and malicious emails and stuff, right? Well, the point that I'm trying to get to is you probably really didn't plan for those things. I would be surprised that very many people are overly worried about ransomware, like it's not stopping them or preventing them from wanting to conduct research or wanting to participate in those things. And that's okay. That's what my office does, right? That's what we're here for. We're here to plan for those things and to help protect you and to help protect data from those things. The other part of that is, did you notice all of these things that we were doing, these emails that we were blocking, the vulnerabilities that we were helping to protect from being exploited? You probably, hopefully, you didn't really notice us protecting those things. And that's fine too. But one of the concerns that's been presented to us is that the idea of data security is almost used as a way to, as an aversion to participating in open research initiatives. People using kind of the blanket term of, well, we can't be involved with that. We can't get involved with that because the security would be too big of an issue or that'd be too big of a nightmare. And what I'm trying to get across is data security is what my team is doing. That's what we're here for, and we're here to help you. So if you have questions, if you have concerns, those type of things, you can come to us, and we will help you guys however that looks. You're already heavily involved in data security. That's another aspect of this. Data security is permeating everything in your life, right? Cell phones, mobile devices, just coming to work if you're working remotely, right? All of those things are things that our office is helping to protect. And you're doing it whether you realize it or not, like you're involved in that already. So I don't want people to be concerned or have this idea that, oh, data security is going to be too impossible to overcome, or there's just going to be too strict for us to deal with. So I guess we'll just opt out of participating in this, or we won't concern ourselves with it. Like I said, that was just a concern that had been presented to us. So that's where I wanted to go with discussing those things. But so what about next? What do we have coming up next? So just to kind of make you guys aware and kind of talk about some of the things that we plan on doing. We've already started working towards a zero trust security architecture. That's a complete reimagining of data security at OSU. We've started the process already, meeting with stakeholders, not just from OSU, in Stillwater, but the other branch campus schools and the other schools in our A&M to help design a framework and how we're going to start bringing these new security concepts to OSU and help protect data, especially with how people are doing research now, with how people are doing work now, how people are living their lives now remotely, not always necessarily on campus, not always at a secured facility, and how do we address and compensate for those things. We've also already engaged in discussion with departments around OSU to bring updated, relevant security awareness content to employees and students. And opportunities like this, thank you, Kay, for inviting us, allow us to just increase awareness about data security at OSU, which is something that we're all about. We would love to have any opportunity that we can to discuss what we're doing and how we're accomplishing it with people around campus. So it helps everybody to kind of have a plan of what they're doing and what they're working on. So with that said, I'd like to turn it over to Daisha so she can discuss having a plan.
Let me unmute. Okay, so thanks, Aaron. This has been really great to hear everybody's perspectives on open science. I'm really, really excited about this topic. I was really excited to participate. So I'm going to try and, get through as quickly as I can and not just like speed through everything I have to say, but I want to be respectful of our time. So it is about planning, and the remainder of our time, I'm going to talk about that, but because it's open science and that's what we're talking about, I want to take a moment and just address the great trade-off that is security. What is good data, or what good is data to us if we can't even access it? So that's kind of a mindset you have to think about when you're thinking about security is, we can put all kinds of security in place, but if you can't actually do anything once we've done that, what good was any of it anyway? So I'll start with that. I'll let you think about that in the context of open science and what we're doing here. But security is balancing those restrictions, that usability. The previous speakers have given us an excellent case for open science, the framework around it, the tools available. And Aaron gave us a great perspective on OSU's resources and a foundation that we've laid for securing your data. So it's your turn now to kind of find that balance with your data, your research, and security. And I hope to give you like the finishing touches on how you can address the risks to your data in the most simplest terms. So we're going to start with just a security program is a written down plan for the most part when it comes to regulatory compliance or anything of that nature. They expect you to have it written down. And Clark spoke to it, and Kay, talked about approaches with fair data, and Karen emphasized the importance of planning. I think that we've really driven home that point is it's all about your planning. And you can incorporate what, everyone has shared here to really secure your data while also planning to open it up. So the security things that I'm going to go over here is the CIA Triad. Real briefly, we'll go over this framework for addressing security. And then we'll talk about relevant resources at OSU, what it looks like real time. And then removing those obstacles are some big dream stuff that I want you to think about when you're doing your research, planning your research, so that you don't have to worry too much about, opening it up. So the CIA Triad is confidentiality, integrity, and availability, or accessibility, pick your term. The context for security reasons is a framework to address all potential threats, or get a good grasp of it. The context for compliance and regulations with the CIA Triad is to address the effectiveness of your security program. And then risk management really is all of that with an emphasis on complexity, methodology, and strategic thinking. So getting into it a little bit, confidentiality. I've given you a little bit with each one of these. My slide's not showing up quite right, but Confidentiality is about ensuring sensitive data stays restricted to those who need it and out of the hands from those who don't. Most commonly, we think of passwords, protecting whatever's behind the password and limiting others from accessing. The authenticity, accuracy, consistency, legitimacy of your data would be the integrity of it. I want to avoid like database technobabble here, but there's a multitude of ways to do this. I've listed a few of them. I've tried to keep it kind of high level. Ways that you may see references, and you can look up those terms if you're not familiar with them. But you want to prevent, detect, or correct any corruption or unauthorized alterations of your data using access controls, checksums, or backups. So if anything goes wrong, you can return to a good point. And then lastly, accessibility and availability. It's about being able to actually get to the data that you're authorized to get to when you need to get there. A recent example I heard was with like if you're trying to purchase a ticket for a concert or event, but it gives you a certain amount of time for you to purchase that ticket, and then it keeps timing out on you because the system's so bogged down. That's an availability issue that we don't necessarily think of when it comes to security, but that's a risk to the business if they can't actually conduct those transactions. So when you're thinking in your data purposes, we're thinking backups, retention, and where you end up putting that data or how you store it. So how do we cover these bases with the CIA and put this information to use? So we want to classify our data and bring it together in your data management plan. So classifying your data is really about determining the course of your action. If it's, sensitive, private, regulated, we want to give it a real defined space so that you know what you need to do with it. So make a list, classify your data, and keep it simple. OSU has a data stewardship policy, and it helps to, it can help you with our public, internal, regulated, or confidential data classifications. But most classifications don't go above 5 levels. So you can set your own classification. Maybe your funding does that for you, but you want to classify your data so you know what to do with it. All that's left after that is you write it down in your data management plan and how you're actually going to secure it. So I've given you just a very rudimentary kind of look at the kind of things that you want to include in your data management plan in thinking about everything we've talked about with the CIA and classifying your data. But also we want to talk, think about open science. It's recommended to have some README files, licenses that Kay, I know, mentioned licensing for how you use the data. Those are all part of your plan, and you'll want to write those, and that can be part of your security plan going forward. You can control how that data is handled as it's shared. So I think I have enough time to just real briefly talk about dreaming big, because you can always change your mind a little bit down the road on how things need to be secured. And technology changes so fast and dramatically that I don't want us to get bogged down on where we are right now. So the data risk news tells us today that we can dream big. So I'm not going to go into these in any kind of detail. I just want to throw them up here, let you consider them. Blockchain, I've read, can be used for the integrity, ownership verification for research data. Fully homomorphic encryption is super cool. I'm very excited about it. And it's basically you can analyze private data without decrypting it. So it can stay encrypted and you can get accurate analysis from it. Super cool stuff. And then the secure multi-party computation. We already kind of see this a lot already, but they're talking about using it for authentication purposes. So if that's something you're really interested in, you could dive deeper on that topic. And then I also wanted to mention that there's standards out there for trusted digital repositories. When you're thinking about securing your data for long-term open science, you're going to want to think about the repositories. And I'm sure Kay is a huge resource on this topic that you could probably talk with her about those options out there. But trusted digital repositories, there's standards already for you to assess them to make sure that they're trustworthy for a long-term plan for your data. So Your sensitive data will be securely shared in the future if you choose to do that, which I hope you do. So you can plan now with today's technology because someone's out there right now doing the R&D on tomorrow's tech, so you don't have to worry about it. So I really wanted to drive that home today for the whole benefit of this group. So I tried to talk fast, but not too crazy. So that's what I got. Thanks, y'all.
Real quickly, Daisha, can you just tell me what RISE is? You had it there with OneDrive, and I don't know RISE.
Sure. And maybe Aaron can also help me on it. RISE is actually the Research Compliance Office has started doing the RISE project. They're still working out the details of their processes around it. But it's for federally regulated data. It's for all kinds of regulated data, but they're putting that together right now.
It's a virtual computing platform. So if you had a specific project, you could have a specific RISE instance for you. And it's set up to be able to meet certain regulatory standards. The NIST 800-171, I believe, the confidential unclassified information requirements for it.
Okay, yeah, I remember now, but just forgotten. Thank you. Okay, Clark, what do we got for questions?
Right, Kay, maybe this one you can answer. Are there any sessions at the library where we can look for data from such sources so we know what's happening as we look at open data sources? So maybe either sessions or services that we provide looking for open data?
Okay, this is going to be hard to answer succinctly because there are so many options. You can actually search for open data sets in the library catalog. And I think we have a guide set up to show you how, but if not, please contact one of us. It depends a lot on what type of data you want. If you're looking for research data for a specific to support a research project that you're doing and it's in a certain discipline, then I am more than happy to help you do that. You can search open data repositories. There are so many options. So yes, please, if you have that need and need some guidance, I am absolutely available. The folks up in government documents can help because there's a lot of information available in government, public government databases. And yeah, just contact your friendly local librarian and we will absolutely get you started.
This was a question that was submitted prior to the event, and it's from looking at it, maybe one that Kara may like to answer, but I'd like to invite anyone to ask or to answer. And that question is, some PIs have the perception that preprints that share novel research findings will be used by competing labs to publish before them. Can you discuss this issue?
I'm happy to chime in on that. It's something that I've spent some time thinking about and talking about with other colleagues in the field. I don't know of many instances where there have been issues with that happening. And now there are so many preprints that are posted. And so I think that while there may be some slight risk of that overall it is, in fact, probably a very, very slight risk rather than one that is commonplace.
Thank you, Kara. Aaron or Daisha or Kay, did you want to add anything to that?
I guess I'm just going to add, with regard to data sets in particular, that's kind of one of the places where the combination of the license and you always have the option of embargoing, if you don't want the data set out there until the publication, hits the presses, then you have that option. And most funders who are, encouraging, shall we say, you to make your data public will allow you that option. So there are some guardrails that you can use, but yeah, it kind of just is a level of comfort, paranoia, whatever you want to call it, that I'm not entirely sure how to address.
So if anyone has any questions, please feel free to put those in the Q&A or raise your hand. Kay, you asked a question in the chat. Can you talk about how you document your analytical workflows? Do you want to expand on that?
Yeah, actually, Kara, what I was going to ask about there is what platform do you use? How do you do it? I mean, is it a Google Doc? Do you do you have elaborate workflows set up in some sort in Microsoft products, or how do you make it work?
Yeah, absolutely. So I have followed the project tier protocol for documenting my analytical workflow. And if anyone's interested in that, they have a lot of guidance and resources on their website about that. I should have mentioned that during the talk. But what I do is I am documenting what I'm doing in my statistical analysis software for the most part. And so the softwares that I use allow for coding or syntax to be written or created alongside the analyses so that those analyses can be reproduced. And so that's what I do that works well for me. I'm not familiar with processes that happen outside of the analytical framework, so I can't talk about those, though those may exist for people whose software doesn't quite fit for what I'm doing.
Yeah, that's kind of why I asked, is because I've worked with various researchers who have different needs, and I never quite know where to point them as far as where to create, because a lot of times they both create procedures, but they also want to track things and so on. And I know that we have some in our Microsoft 365. We have some tools available for some of that, and I know there's like Trello and things like that, but anyway, I don't know how much trouble people are willing to go to set those up to use them. So that was kind of why.
So Aaron and Daisha, you mentioned the data stewardship policy. Is there anything that you think that the OSU community needs to know about that specifically, or anything else you want to say in relation to that policy?
Sure. It's a great policy. It does assign some accountability, so it's important to read through it and to be aware of it, especially as from all aspects from top to bottom. It covers the data stewards, the data custodians, access custodians, all the way down to users. So even as a user of institutional data, you need to be aware of that policy. It doesn't get very prescriptive as far as the actual handling of data, but it does set expectations for who will prescribe those expectations. So PIs are within the scope of it, so it is important for research groups to know about that policy and how it functions. It's very hierarchical. And because it's not super prescriptive, it does give room for, setting your own expectations for your data and within the parameters of that policy. So.
Clark, while people are thinking of questions, hopefully I wanted to mention that you are probably aware that this is being recorded, and it will be available once the recording is curated a bit. It will be available from the Cadre website. It will be linked to the Cadre website. Also, Clark has already put a link for his slides in the chat. I will make mine available. And if the rest of our panelists are also willing to make theirs available, we'll make them available, linked to the website as well. So.
Any more questions in the last few minutes we have here? Anything that our panelists want to say that you didn't get a chance to say?
I'll just repeat that I'm very excited about this whole initiative because I think it's really important as a research institution to, push for some open data. I know it's not always doable, but it's just really important to not be afraid because, security, from our perspective, from Aaron and my perspective, it's just easy to, say we can't do that because yada, 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 security reason. But it doesn't have to be that way. And the technology out there is so cool. So you just got to look into it.
Citation, Aaron, is there someone that you would recommend in IT for researchers to touch base if they're needing help or guidance with data security, with sharing data?
You can start with me. My information's, in the slide deck that we're going to share in on the website for the symposium. And you can start with me and I can get you to anybody that you need as far as a technical resource. Absolutely.
Thank you.
Mm-hmm.
Yeah, and some colleges, they have their own specific IT unit as well. So they may be able to help you. That may be where you get redirected to. But some of the colleges have their own specific more tactical units, right, that can help address those specific concerns.
And right here at the end, I did see, so in the previously submitted, there was a mention of someone asking about how to deal with obsolete software. And though, unfortunately, I'd have to see the software, and frankly, that's one of those things that I can see our IT folks kind of looking down, because that's one of those big challenges. The best thing, and this does come under the FAIR data, is to use non-proprietary software. And again, plan in advance for that, because it's so much easier than dealing with it after it's no longer supported. So it's a sad, not a particularly satisfactory response, but I think that's the best I can do without more details. So, all right, any last words? Well, I just want to say thank you so much to you all for participating. I really, really appreciate the and there's more information in the chat. Really appreciate the breadth of perspectives that we had today, and the information that was presented. And I look forward to future Cadre symposia. I think we've got some great stuff coming up. So with that, I thank everyone for attending and for participating, and we will see you next month.